Hello dear student. Hello everyone. Today we will talk about chapter 5, lesson 2, which is Charles' law. Let's go. Temperature and volume. Charles' law, temperature and volume. So first, how is the volume of the gas related to its temperature? As we see from the opposite figure, movable mass or constant pressure. So the relation will be between temperature and volume. What happens if heat is applied to the gas? Sure, as the temperature increases, the volume will be also increases. As you see, as the temperature or the system of the gas is exposed to the fire, which is a source of heat, so the volume increased. Now, as the volume or as the temperature increased, the volume will also increase. So, how is the volume of gas related to its temperature? Or, why did the volume change? And also, what happens to the average speed of the gas molecules? تعالوا بينا شوف الفيجر اللي قدامنا to confirm the meaning of Charles' law. Now, as the temperature increases, the molecules make collisions with the wall of the cavity and also between them. So, as the volume or temperature increases, the volume also increases. As we see, well, volume is directly with T. Next, we can say or we can define Charles' law. At constant pressure, the volume of gas increases as the temperature of gas is also increases. And so on, the volume decreases when the temperature decreases, because all of them, volume and temperature, are directly related. So, increasing the temperature of a gas increases the speed of gas, while or which collide more and more, causing the walls of flexible container to be expanded. So, from the opposite graph, V1 over T1 equals V2 over T2. And also, for example, we heard or we saw well the effect of temperature on the balloon. تعالوا بينا نشوف فيديو about Charles' law. First, the scientist Charles at 1787, which he investigated the relationship between volume and temperature. As you see, at constant pressure, the volume and temperature are directly proportional. So V is direct with T, but at constant pressure, so V equal constant multiply T. So we should say at constant pressure, the ratio of volume and the absolute temperature is always constant, which means V and T are directly proportional. And according to Charles' law, V is direct with T. We can say that V1 over T1 equals V2 over T2. As you see, V1 is direct with T1 and also V2 is direct with T2. So, from equation 1 and 2, as you see, V2 is direct with T2. Also, we can say equation number 2. إذن يا أصدقائي نقدر نقول إنه V1 over T1 زي ما هتشوفوا دلوقتي equals V2 over T2. طبعا يا أصدقائي ممكن نقول V1 over V2 equals T1 over T2. And now we can say that equal volumes of different gases expand when their temperature is increased by the same amount and under constant pressure. As we see from the opposite figure, the two filaments of mercury move equal distances. So the conclusion will be equal volumes of different gases will expand by equal amounts if their temperature increases. Perfect. By the same amount. And also when the pressure is constant. Number 2, when pressure remains constant, the volume of gas, bravo, will increase with increasing temperature. دلوقتي يا أصدقائي هنتكلم عن ال coefficient of volume expansion. Let's go. First, what is the thermal expansion of solids? And also, what causes thermal expansion? First, thermal expansion is a consequence of change in average separation between atoms in an object. As we see, like this, the separation between the atoms or molecules change as the temperature changes. And also, joints are used to separate sections of nowadays on bridges. Also, as we see the molecules, and we know well, the distance or separation between each atom or molecule equals 10 angstrom or 11.1. So we can say that 10 angstrom is the difference between the side is 10 angstrom and the side 11 angstrom, which means the expansion equals 10 angstrom. So we can say that as the temperature of solid increases, نركز يا أصدقائي, the atoms oscillate with greater amplitudes. طبعا خدناها في السمستر الأولاني. So the average separation between them will also increase, which means the object expands. تعالوا بينا نشوف الفيديو ده. Charles' law. طبعا at constant pressure the volume of a given mass of a gas is directly proportional to absolute temperature, which means V is direct with T, and also V over T equals K, which is constant. So V1 over T1 equals V2 over T2. As we see, the relation between volume and temperature at certain value of pressure. And for each straight line or relation, we see well that P1 is less than P2, less than P3, and also for P4. But each line represents a system which is called isobars or isobaric system. So we can say that linear expansion increase in one dimension of a solid. Linear expansion occurring along a line, so linear. Then change in length, what? Perfect, is proportional to both initial length and change in temperature. So we can say that proportionality constant أصدقائي proportionality constant which is alpha. This one is called coefficient of linear expansion. This one is called coefficient of linear expansion. And now we should or we must calculate this one or deduce the relation of alpha to solve the problems. So now average coefficient of linear expansion. First, if we have Li, which is initial length along some direction at some temperature, and Ti, also delta L, which change or increase in the length. So delta L is or means change in the length, maybe decrease or increase. So delta T is also change in temperature. Finally, we can say that the average coefficient of linear expansion is defined as or from the relation alpha equal delta L over Li or divide delta T. But you know well, or you should know well, that delta L equals L final minus L initial. So equals alpha Li delta T. أصدقائي, the two equations are the same, but with two images. As you like, زي ما تحب يا صديقي. Use the first one or the second. All of them are the same. So finally we can say that the change in length of an object is perfect, is proportional to the change in temperature. And now average coefficient of volume expansion. دلوقتي يا أصدقائي هنتكلم بقى عن ال volume expansion. First, VI, which is initial volume at some temperature or at a certain temperature. Delta V is the change in volume, which may be increase or decrease. And now delta T is change in temperature, maybe also increase or decrease. So we can see that the average coefficient of volume expansion is beta equals delta V over VI over delta T. سامع حد بيقول لي ده نفس الرول بتاع اللينير. برافو. But now we are talking about volume, not linear. So by the way, delta V equals V final minus V initial equals beta VI delta T. زي ما قلت يا أصدقائي. Use equation number 1 or equation number 2 as you like. All of them are the same. As we see, if we have change in temperature, maybe change in the diameter, maybe change in volume. So finally, we can solve or found the unknown expansion of volume coefficient by this equation. And now, the coefficient of volumetric expansion of a gas at constant pressure, which is beta V. So first, the amount of increase in unit volume of a gas at 0 Celsius when its temperature rises by 1 degree at constant pressure is equal to 1 over 273. This one is coefficient of volumetric expansion. وممكن كمان يا أصدقائي حد يسألني what is K? K is Kelvin. K is Kelvin, which is unit of degree. But now 1 over T is K minus 1. K minus 1. So the magnitude of volume expansion coefficient at constant pressure, which is beta V equals V100 minus V0 over V0 multiply 100. So first, what is 100? Temperature at 100. What is 0? Temperature of 0. Where V0 is the volume of gas at 0 Celsius and V100 is volume of gas at 100 Celsius. And from this figure, we did the experiment and also determined the volume expansion. And now, shall we solve this one? Let's go. بيقول لي يا أصدقائي in Charles' experiment to determine the volumetric expansion coefficient. برافو. beta of air under constant pressure. لازم يكون في ال pressure constant. The length of air column trapped at the melting point. برافو 100 was 13.65. يبقى احنا هنا عندنا ال V at 100 which is V100 and the length of column trapped at the boiling point of water under normal atmospheric pressure. يبقى الأول نرجع تاني للميلتنج بوينت اللي هي liquidification يعني at 0 بينما at boiling point يعني at 100. What is the value of atmospheric pressure or length is 18.65. هنا بقى بيقول لي calculate the volumetric expansion of air by neglecting expansion of the glass. So beta equals V100 minus V0 over V0 multiply 100. So V100 18.65 minus 13.65 which is V0 over 13.65 multiply 100. So the final value will be 1 over 273 which also 0.00366 Kelvin minus 1. Practical implementation of Charles' law. Let's go. Charles' device setup or installation. طبعا يا أصدقائي زي ما انتم شايفين a glass capillary tube with a length of 30 centimeters. So now we have a capillary tube which is 30 centimeters of length and its diameter is 1 millimeter and it is closed at one end and containing a drop of mercury that traps a quantity of dry air. Also is fixed with thermometer to measure the temperature. On a graduated ruler inside a cylindrical glass containing or container, the cover for controlling the temperature of enclosed air. So the function of container or glass container is control the temperature. Number 2, two pipes, an upper one for entering water, vapor, and a lower one for exiting water vapor. Then two rubber stoppers. So the pipe should be of regular cross section. طبعا يا أصدقائي بعض precautions must be available, such as the pipe should be of regular cross section, such as uniform cross section, so that the length of trapped air column is a measure of the volume accurately. Number 2, the trapped air must be completely dry. Number 3, the column of trapped air should be completely submerged in the cover glass through the experiment. Bravo, to protect or to control the temperature. Number 4, the tube should be kept in an upright position through the experiment without any slope because or to make the values are accurate. So, the steps to experience or to achieve the Charles law in practice. Number 1, fill the glass shell with crushed ice and designate or V1, which is V naught. Number 2, as you see from the opposite figure, we pass water vapor and designate V100. Number 3, we calculate volumetric expansion, as we said before, from the relationship, bravo, beta equals V100 minus V0 over V naught or V0 multiply 100. Number 4, determine the length of the column of air trapped at different temperatures. Number 5, we draw graphic relationship between each of entered air volume and temperature on the Celsius scale. As we see, we draw graphical relationship between each of trapped air volume and temperature. And now, mathematical formula for Charles law. طبعا زي ما انتم عارفين, when plotting relationship between volume on vertical axis and temperature on horizontal axis, we get the following graph. As we see, well, T in or at x-axis and V in or at y-axis. And now we have different volume, which V1 and V2 at different temperatures. So the conclusion will be T is direct with the V, or V1 over V2 equals T1 over T2. So the summary or the overall conclusion from this, which the volume of gas is inversely proportional to its pressure. Yes, so this one is Boyle's law. And Charles' law demonstrated that the volume of gas is directly proportional to temperature. Bravo. And also, Avogadro's postulated that the volume of gas is directly proportional to the number of moles N of gas. So, if we plot the volume of gas versus temperature, which is extrapolate to 0 volume at negative 273.15 Celsius. And this one, or this value, equals 0 Kelvin. So, the lowest temperature is possible is what? 0 Kelvin. نركز يا أصدقائي. If I asked you, the lowest temperature which is possible is, bravo, 0 Kelvin. And finally, we stated that Charles' law implies that the volume of gas is directly proportional to its absolute temperature. إذا يا أصدقائي هنحل مع بعض الexamples على Charles' law. Let's go example 1. If the volume of a quantity of gas at temperature of 273 Kelvin is 450 centimeter cube, and if its temperature is increased to ركزوا أصدقائي ما قلتش increased to 364 Kelvin. So calculate its volume assuming constant pressure. يعني يا أصدقائي عندنا الجيفن أول temperature T1 then V1. So if we have another temperature which is T2, bravo, هيبقى عندنا V2. So solution step will be V1 over V2 equals T1 over T2. So by substitution we have V1450 over V2, which is X, equals 273 divide 364, which means V2 equals 600 centimeter cubic. Example number 2. A quantity of gas whose temperature is 27 if its volume doubled. يعني يا أصدقائي V2 is double V1. يعني V2 equals 2 V1 at constant pressure. What is its temperature? So the solution will be V1 over V2 equals T1 over T2. So V1 over 2V1 equals 27 plus. أصدقائي هنا هنعمل plus 273. ليه؟ لأن احنا لازم نعمل convert from Celsius to Kelvin over T2. So the final temperature or the second temperature will be 600 Kelvin. Example number 3. A quantity of gas at 17 Celsius. Don't forget. اوعوا تنسوا يا أصدقائي برضو هنعمل plus 273. ليه؟ لأن احنا بنشتغل بالابسوليوت temperature اللي هي Kelvin. So a quantity of gas at 17 Celsius whose temperature is raised by 100 Celsius while its pressure remains constant. طبعا يا أصدقائي pressure should be constant. So this one increase its volume by 2.5 centimeter cube. The question: calculate its volume before heating. طبعا يا أصدقائي. So V1 T2 equals V2 T1 or V1 over T1 equals V2 over T2. So by substitution V1 multiply 17 plus 100. لأن هنا يا أصدقائي قلنا raised by يبقى لازم نعمل plus. طيب لو decreased by لازم نعمل minus. So 117 plus 273 equals V2, which is V1 plus 2.5 multiply T1 17 plus 273. So by using your calculator, the V1 value will be 7.25 centimeter cube. Example number 4. Complete the following statement. When the absolute temperature of a quantity of gas at constant pressure is doubled, the volume is برافو اللي قال لي doubled. تعالوا نشوف السوليوشن بتاعنا أو الإكسبليشن ستيب. الإكسبليشن عندنا بيقول as you know well V1 T2 equals V2 T1. So by substitution with the givens, so V1 which is at 2 equals 2V1, which means V1 2 T1 equals V1 2 T1. So the volume is doubled. تعالوا ناخد the final example. An open container with an internal volume of 2.05 liters placed inside a cooler at temperature of 5 Celsius. If it was taken out of the cooler, نركز مع بعض يا أصدقائي, until the temperature of the container became 21 Celsius. So we have V1, we have T1, and also we have V2 and T2. The question here is calculate the volume of the amount of air leaking from the container, assuming that both the pressure and volume of the container are constant. So by the way, we have V1 over V2 equals T1 over T2. And from given, we have V1 is 2.05, but we don't have the value of V2. So V2 is unknown, equals T1, which is 5, but plus 273 over 21 by the same plus 273, and using your calculator, the value of V2 is 2.17 liters. So the volume of air leaking equals the final value minus the initial one, which may also is called delta V, change in volume. So equals 2.17 minus the initial volume, which is 2.05. By using your calculator, the value will be 0.12 liters. And with this, we have finished this part, and also we have finished the lesson. Thank you for all. See you again and goodbye.
فهمت الدرس؟ ده وقت التطبيق مع تدريبات واختبارات نافس. حمل الآن.